Hi, my name's Ingrid Orlake, and this is a presentation I gave for the Women in Big Data Data Challenge. When the data arrived, I could see in the preview that it was comma-separated values, and I opened straight away in Excel, of course. I could see that the numbers were between 1 and 26, and the column headers were letters of the alphabet. I'll tell you later on why statisticians don't like getting their data in Excel spreadsheets. To see anything further about the data, I needed to put on my X-ray specs and have a good look. I opened up the data in R and I issued the summary command. So for the 111 columns, it gave me 6 figures for a summary for each of the variables. There's the first 8, and here's the last 7 of the 111 variables. So I thought I'd had a reasonable look at it, but it turned out I missed a couple of things, and that's the problem with using summary command for this amount of data. In column BX, I didn't see that unlike all the other columns, the minimum value wasn't 1. And in column BK, I didn't notice that the summary command was telling me that there was a couple of missing values. I went ahead and plotted the data in box plots, and then I noticed that for column BX, the minimum value isn't 1. The medians of these box plots aren't very interesting. They're just sitting around the midline, not doing anything too special. I thought I'd better have a look at the rows because the variables weren't giving anything away. The rows have got a lot more with non-minimum value 1 and non-maximum value 26. But more interestingly, the medians seem to be a little bit more interesting. Between rows 84 and 96, the median is sometimes the same as the value of the lower quartile in the adjacent box plots, so that's quite interesting. But now to explain that why there's so many missing 1s and 26s for the rows that aren't missing for the columns, it's simply because there's more data in each column. So in each column, you'd expect 6 or 7 occurrences of any particular number, and in each row, you'd only expect 4 or 5 occurrences of any particular number. When I was looking at this, I noticed that 26 is 2 times a prime number, and 172 and 111 are also small multiples of prime numbers. So not only did this data not have any backstory, it also had nothing of a pattern in the ways of 7 days of the week or 24 hours of the day to put a statistical little story around. So there's the plots of the box plots. And as I said, the rows are a little bit more interesting than the columns. I decided to, instead of just looking at medians in the box plots, that I would like to look at the means of the data because sometimes they can be a bit different. So that's the means of the rows of the columns at the top. And this is the first time I noticed that column BK has missing values. The plot of the means of the rows at the bottom shows that the missing values are actually in row 75 and another one in row 161. So the means of the variables at the top don't do anything too interesting. They just sort of hang around a midpoint. But the means of the rows are a bit more interesting. They seem to rise initially, then there's a missing observation, and then there's a bit more variation amongst the means, which are a bit lower. There's a second missing value, and we don't know at the end if the series has righted itself or whether it will do something different next. But I thought I'll treat this row means as a time series, and that might produce an interesting story for a competition entry. So I used the FP2 package in R, and I redid the plot. So that's the same plot as on the previous slide, but it's just squashed and stretched out up and down. And you can really see that there's a rise and then a fall in the data. The autoregressive function gives you a clue as to what sort of time series this might be. And I tried it, and it said that it's a moving average series of order 1, but that if I took differences, I might be able to get rid of my non-stationarity problem. That's the rise and the fall in the data. So I did that, and there's the rise and the fall is not there anymore. It's still a moving average series of order 1, but it doesn't need differencing. So I thought, okay, well that's pretty interesting, and maybe that's my competition entry, and I'll just submit a little story around that. But overnight I slept on it and thought I better have a good look at all the data. So I did an image plot, and what I could see from this with the default 12 colours is that there seems to be a bit of an excess of red in the top right corner. But since there was 26 numbers in the data, I decided to use a 26 colour palette instead, and the new plot looks like this. The red is sort of replaced with orange now, and I could see straight lines in the orange, and I could even see what I thought might have been some sort of letters. At this point I could also see that in the middle there's a bit of excess sort of green, so I thought, all right, I need to plot every number individually. So this is what I did. I found that it actually says data should be seen, and the numbers that are causing the words data should be seen are the numbers 23, 9, 2 and 4, and they correspond to letters WIBD, women in big data. So after that I straight away thought data should be seen and not heard. It must say and not heard somewhere, it's got to. So first thing I tried was k-means clustering, and you need a starting point for that. So in amongst some of the colour plots you can see there's a couple of white specks, which is where those missing values were. So I thought maybe they should be the starting point for the k-means clustering, and I tried, but it wasn't successful. And I also tried hierarchical cluster analysis, and that wasn't very successful either. So I thought, okay, well maybe I need to give up on the and not heard. But I thought this is very noisy data, and I want to do a little bit of trying to clean up the data a bit. So first I made the 26 colours shades between white and black, and I applied a 2 pixel median blur, and it did help a little bit. You can see in the top plot in the middle. I think it's a little bit clearer, but when you do a 3 pixel blur, all the good effect is gone and it just looks like a smudge. But however, when I did it with 2 colours, black and white, and just applied a 2 pixel blur, I was amazed that it's done such a wonderful job of just picking out the letters and the words much better. The 3 pixel blur is no use though. So I had given up just about on seeing the words and not heard, but I want to go back to why statisticians don't like people bringing data in Excel spreadsheets. So what I did is I minimized the sizes of the cells in the spreadsheet, so you can't even see the numbers anymore, but I applied a cell format, and that made the words data should be seen come out. Then I made some accidental changes to the data, which is what can happen when your client brings data in an Excel spreadsheet, and I put some numbers 666 in some of the cells, and I decided I was going to format those cells with the color red. And this is what happened when I did that.